But we also need to think about, well, what happens when we actually want to run a real production application? Second John, LLMs are stateless. They don't know anything. They don't remember anything. When you call them, you have to give them data. You have to give them context. From one call to another, you have to give them context. The more context, the more data, the more information you give them, the better the results. And you want to do that when you're constructing a prompt. When you send a prompt to OpenAI, chat completion, the more data and the more relevant data you can put in that prompt, the better results you're going to get. The data that you want to put in those prompts, you already have, right? It's not data that you're making up. It's data, especially for your private data, on your own data, not public data that you can scrape from anywhere. On your own data, it's data you have somewhere. It's stored in a database somewhere. It's in a data warehouse. It's streaming maybe on Kafka, but it's data you already have. So how do you get that data that you need for the prompt with high quality response back from your generative AI application into the prompt at the time that you create the prompt? And things are moving fast. Every day there's something new. On the application formerly known as Twitter, there's new advances all the time in this domain. You want to stay on top of this stuff. How are you going to do that? So our solution, our proposed solution, and a day early, is Langstream. Langstream is a framework for building generative AI applications. You build using LLMs and vector databases. Those are the two main components of infrastructure that you need. Okay. Now, it integrates with all the popular LLMs, like OpenAI, Google Vertex, Hugging Face. This is bring your own LLM, by the way. We're calling APIs for all of these services to get the completion. Langstream lets you bring your own data to the prompt. Bring your data to the AI. You can build a data pipeline that allows you to construct a vector similarity search and then insert that into the prompt at the moment you call the LLM for a chat completion. You can also do database queries, standard database queries from Postgres. DataStax is the Cassandra company. Obviously, I'm going to show you how to use the queries with Cassandra. You want to be able to get that data at the moment of constructing the prompt. And in the way that happens when you need to pull that data, you need to integrate it all in at that moment. Langstream is a declarative low-code mechanism for building applications. Okay, you can, with configuration-driven, basically YAML files, construct a whole generative AI application, which I'll show you later. You can also integrate custom agents using Python. So you can write your, if the low-code configuration-driven agent isn't good enough for you, doesn't have all the functionality that you need, you can use Python, you can import libraries, you can use common libraries like LangChain, LlamaIndex, they're all supported. The other thing you can do to get your data in there, Langstream is fully compatible with Kafka Connect. So you can run any existing Kafka Connect connector within the context of Langstream to pull your data from databases or to get your data if it's real-time streaming data. And I think the most exciting part for me about Langstream, because I'm head of streaming engineering, is that it's an event-driven architecture. And I think there's a lot of advantages to building an event-driven architecture. Fundamentally, the calls are all asynchronous, right? Everything is decoupled. Because we are using standard streaming, we're basically building a streaming pipeline here. Standard mechanism for logging, scalability, these kind of things all apply because of the architecture we use. We built it on top of proven technologies. We're using Kubernetes for resource scheduling and for fault tolerance or fault recovery. And we use Kafka for the topic management. So I'm going to give you a little overview of what our example app is going to do. The first thing you want to do is get the data we're going to build a chatbot. Okay. We're going to build a chatbot, and you want to have this chatbot know about your own data, right? Not public data. First thing you need to do is get the data, the text, PDFs, CSV files into a vector database. And so the first pipeline of our LangStream application is going to do that for you. What it's going to do is you're going to take your files, the PDF files, the text files, the CSV files, you're going to drop them into an S3 bucket. The pipeline is going to pick that up. It's going to read those files. It's going to convert them to text. So the PDF file is a binary file. It's going to extract all the text of that. And when you're doing a similarity search, it's important that you don't use very large pieces of text. You want to have smaller pieces of text so that you get relevant, very large similarity. When you do a very large search on a document, you're going to get too much data. There's limits on how much data you can send to that element. So what you want to do is chunk up your documents, your text, into smaller pieces. So that's what we're going to do. We're going to break up the text into smaller pieces. In this case, we're going to target about 400 tokens on the size of the text that we're loading to the vector database. And that's for because we're looking to call OpenAI GPT-4 here. Right. Then for each one of those pieces, those chunks of text, we're going to calculate a vector embedding. We're going to do that using OpenAI's ADA02 embedding library. And then we're going to write the chunk of text plus the vector into AstraDB, which is a vector database compatible database. That's our first pipeline. Our second pipeline is the backend for the actual chatbot. So what it's going to do, it's going to receive a question on a topic. And it's going to take that question and it's going to calculate a vector embedding for that question. So now I have a vector for a question that's being asked, and the database, the vector database, contains vectors for all of the private information that they have. Using that vector from the question, it's going to perform a similarity search on the vector database. It's going to get a bunch of responses. In our case, we're going to get 15 chunks of text that are semantically similar to the question asked by the user. We're going to then insert those semantically similar chunks of text into the prompt and then we're going to send that prompt to GPT-4. GPT-4 then is going to generate a response, and we're going to send that back to the user. That's the backend part of the application. The front end is, this is where the Vercel part comes in. We're using a template from Vercel to build a front end. It's really, Vercel is really easy to build front end applications and deploy them. So we've taken a template, we've modified it, we've deployed it in Vercel. The one modification we did from their template is we replaced the calls that normally in that application goes directly to OpenAI with a WebSocket connection. Because everything here is going to run on WebSocket connection. WebSocket connection for sending the question, a WebSocket connection for receiving the response. So let me try this live demo. Oh. Okay. So the first thing I'm going to show, is this big enough? This is the first pipeline, the text, what we call the text processing pipeline. It's with LangStream, you declare the pipeline, and I'll show you in a second in a YAML file, and then it automatically will figure out how to render this as a working pipeline using Kubernetes pods and Kafka topics. That's what it'll look like when it's running. The code looks like this. See that? So it's a simple YAML file where we define a pipeline, and the pipeline is a series of steps or agents that it goes through in a series. So the first thing it's going to do is read from the S3 bucket, and then we're going to extract the text from whatever's in the S3 bucket. We're going to split that text into chunks. We're going to do a little bit of cleanup of the data. We're going to add some metadata. Let's kind of skip over that. And here, this is where we'll call the OpenAI API to get a vector embedding Yep. Sure. Oh. That better? Okay. So here we're calling the OpenAI text embedding model to get a vector. That's a 1536 dimension vector. And then we're going to sync that vector into our AstroDB vector database. And when we do that, we're going to write out several things into the database: the name of the file that it came from, a chunk ID, what language it's in, the actual text, and the vector. This is all stored in the one table in the database. Let me just quickly show you how that works. So this is my AstroDB database. It currently has a bunch of chunks in it. It'll take a little while to. So the data that I have here is from a project I was working with, an AI startup that is building a chatbot so you can talk to notable figures. And the idea there is they've collected a lot of podcast data, and they've done transcripts for all the podcasts. And they've provided me here with the podcast data, and that becomes the input, the private data in this scenario for our chatbot. I got 17,000 chunks of data in here. It would take a little while to process all of that. I'm going to show you one file, how we process it. So right now we have 17,821 chunks in our database. So we're just going to go into S3. I'm going to take this file, which is it's a transcript from one of the podcasts. I'm going to upload that into S3. And that's going to get processed automatically. When it's done processing in S3, it removes it from the S3 bucket. If we go back to the database and we query the database, why is that not showing? Sorry about that. It's not showing the terminal scrolled off the screen. If you can remember the number of chunks that were in the database, I'll find some socks for you later. Yeah. Okay, the number before was 17,821, and now we have 17,876. So we've added about 50 more chunks into the database just by adding data to that S3 bucket, which triggers the pipeline. It's coming from raw text that's getting read from the S3 bucket, and then the pipeline processes so say it's a PDF file. We're putting this in the S3 bucket, or this? We're putting this into the S3 bucket, and the pipeline that we've defined in the YAML file reads files from the S3 bucket, detects if they're have text in them, like PDF, and then it will chunk. If it has text in it, it divides it into chunks and then calculates vectors for it. So this is after. This is after I put it in S3. I could show you a row from this, but it's got vectors in it, so it's like 1,500. You put a PDF S3. That's right. Yeah. Yep. So this is how we can automatically update our vector database with new data, and so the chatbot would be able to use that. So let me show you the chat before I go on. I'll show you the chatbot pipeline. The chatbot pipeline is a little more involved. It reads on the left-hand side there, it reads from the questions topic. From the questions topic, it does a bunch of cleanup. And one of the things that we have in this particular example is history of the chat conversation. Because when you're building a chatbot, you want the chatbot to remember what's happened in the conversation previously, because it sounds kind of silly if it doesn't know what you were talking about when you refer to, in your normal conversation, you refer to things that happened in the past in the conversation. So what it's going to do, and it's hard to see here in the visualization. Let me switch to the code, the YAML representation of the chatbot. Oh, this is the wrong one. Sorry. Okay. All right. So the question comes in on the questions topic. We computed embedding here in this step for the question. Using the same embedding model that we use to store the data in the vector database. And the next step, we're going to do a semantic search in the vector database for documents that are similar to the question, or for text that's similar to the question. We're getting 15 chunks of data in this case, chunks of text. We're keeping track of the chat history here, so we're also going to query our database for the history of the chat conversation. And then in this step, we're going to actually build a prompt to send to the LLM. Prompt to the LLM is just text, but we can do a lot with the text prompt engineering. We can add some examples of the kind of answers we want. This is called few-shot learning. And then we're injecting the results that we got from the semantic similarity search in the interview abstract section of the prompt. And then we have the chat history. And can't read all of the prompt right now, but what it says is answer the questions using the text I've given you. Don't make up stuff. Okay, because one of the problems we've all probably experienced with ChatGPT and GPT-4 is that it'll hallucinate, it'll make up answers. And we want to prevent that from happening. We want to ground the responses in the data that we've sent it. So if you were to read the details of the prompt, you'll see that it says, in your answer, always consider the data that we've given you. From here, it's going to just clean up it's going to do some manipulation on the data in the pipeline. And then at the bottom, it saves the chat history into the table. Okay, so after all of that, let me show you the actual chatbot. So this, let me make it bigger. As I mentioned, this chatbot is built on top of podcast data. The podcaster in this case is Preet Bharara, who is a lawyer, former politician, former lawyer, former U.S. attorney. He does podcasts now about law and politics. Okay, we can ask questions to the chatbot, and it'll tell us about what's happened in the podcast that he's done. All the 17,000 pieces of text from the podcast. I'm going to ask the question, tell me about the space race. And I had in the past a way to look at the processing that was happening in the background. The chatbot has given me an answer. It's gone through that pipeline. It's done a similarity search in the vector database, pulled out text extracts, put that in the prompt, and generated a response for me. You can ask follow-up questions. This This question referred to a person named David Ignatius. We can ask follow-up questions about David, and you get the response back from what he talked about explicitly in the podcast. And just to show you that it will give you answers, it won't make up answers. I can't type very well. Let's ask it about soccer. And it says, I'm sorry, but the interview extracts provide no information about Women's World Cup soccer. So it's grounded in the actual data we sent it. If this semantic search returns no relevant data or very low relevancy, then it'll say there's nothing relevant here, and it'll move on. Yeah. Yeah, we're using prompt engineering. Yeah. Yeah, we give it specific instructions to say only consider the extracts of the podcast that we've included in the prompt.
So for you, like this one, it's very easy to see the notes.
Yes, it will always give you 15 results. Now, one of the things we haven't done, but there is metadata we could extract to say the actual similarity ranking for that, and we could include that in the prompt and instruct it to consider that when it gives the response. This is fairly simple, but it's pretty reliably giving us grounded results from that. I said in the title, it said 10 lines of code, so I'll just show you some code. It's very small. This is the code in the front end that we replaced. The top one is handling the send to the WebSocket. The bottom one is receiving a message off the WebSocket. That's the only code that we changed in the Vercel chatbot template. Now, one of the interesting things to me about this architecture, the streaming event-based architecture, is that it's easy to extend it, right? Imagine a chatbot that was actually not just waiting for you to ask a question and respond to you. Imagine a chatty chatbot that actually tries to talk to you and get you going in a conversation. So one of the things that we can add here very easily by building another application that taps into the same set of topics and the pipeline is a keep alive for the conversation. If the user hasn't asked a question in a while, this pipeline will try to get the conversation going for more engagement. And that's because we're doing streaming here. We're not sending a request and waiting for a response. We can asynchronously send data to the chatbot to the front end anytime we want. And I can find the window. So what I did is I wrote a small Python application that will try to keep the conversation going. If it detects that nothing's been said for a while, it will inject a reminder to the LLM to come up with some kind of conversation starter. We'll see if this is going to work for me. This is a simple application. Every 40 seconds, it'll try to keep the conversation going if it hasn't seen any new responses. And it's not going to work in the demo. Trust me, this worked earlier. This will come back and you will see, normally you see the back and forth right between the human and the bot. The bot will start talking to you, saying, it comes up with, I see you're interested in the space war. It'll say, do you want to talk more about that? These are the kind of things. But because the architecture, we can do that, and we can easily add this stuff on, bolted on essentially onto the application without even modifying the existing application. Okay, and the last thing I'll mention about Langstream is we see it as a development environment, an easy way for you to build applications. We've launched a VS Code extension at the same time as the project, which will officially be launched tomorrow, and you'll be able to take a look at it. The VS Code extension is available actually right now. It's released a little early in the marketplace. This will allow you to you can obviously code your application. It has snippet support, so it can actually quickly add new agents here into the configuration, and you can also view. It's hard to see here. You can look at your application and the components of it. We also have DataStax has a cloud service called Astra, which is what I was using for the database, the vector database. We have a private preview running, and that's the visualization that I showed you is in Astra, that you can run all of this without actually in a cloud service. If you want to try it yourself in the open source project, you can install Minikube and run it as a Kubernetes application. It's built using Kubernetes operator, and it uses all of that infrastructure, proven technology, as I said earlier, to spin up pods and recognize the different workers that are part of the engine. So as I mentioned, open source project Langstream on GitHub. Feel free to clone it and please start if you think it's cool. Private preview, that'll open up tomorrow. The QR code is to register for Astra. And you'll see once you're in Astra, you'll see Langstream in the UI, and you can register for the private preview. We've started a Slack channel, so if you have questions about Langstream and you want to get some answers from the team that built it, go onto the Slack, and that's the link for the VS Code extension. Do I have time for some questions, Bill? I'm out of time. What's that? I can take questions afterwards if people have questions. Okay. Couple questions. Anyone?
The chunks, are they kind of similar to keywords in big vector, or are they separate vectors in vector database? The chunks contain like duplicate data. Multiple chunks contain some of the same data, but it's not.
Yeah, I didn't show that detail. That's a configuration option in the when we calculate the size of the chunk. We target a token size for that. So it's not a word count. It's based on tokens, and it uses the tick token model that's provided. There's a tick token library provided by OpenAI that allows you to calculate the number of tokens that a particular piece of text has. So we use that library so we come up with an accurate measure. But you can also define an overlap. So this is a best practice for similarity search because the semantic meaning may not. If you just arbitrarily divide it, so you want to do some overlap between your chunks.
And it's like each chunk a vector? Or
each chunk is a vector, yeah. So for each chunk, it calculates a vector and saves that in the database.
Search works.
And the search works on you take the question as a vector, and it does a vector search, approximate nearest neighbor search on the database.
Thank you.
You're welcome. Any other questions?
Last question. Ready? All right.
From what I understood, is this the chunks? Is it just a workaround the 4K limit by channel by OpenAI?
Yeah. So I mean, you have depending on the model, right? You're going to have limit of the context, the amount of tokens. So what we're targeting here, when we originally developed it, we were using Turbo 3.5 as a 4K context window. So you want to make sure that you have enough token limit to get an answer back. So we were targeting about 2K token limit token for the prompt and all the vector all the vector semantic search results. You have to take that into account when you generate the prompt. All right. Right.
Yeah, very great. Thanks for the presentation.
Okay, I think it is going to be fine. All set.
All right, so let's start back. Let's get started in 1 minute. Let's come back, text it, and we will start in 1 minute.
干嘛？比这个干嘛？
这个可能是切换屏幕什么之类的吧。
不要搞。对，哦，我要拿这个的时候。
对，等一下我稍微介绍一下你。
对 ，OK。
Okay, so welcome back. Let's get started our next speaker, Yu Xi. He's going to talk about iterative improvements from feedbacks for large models. Yu Xi is the founder of RL for Real
Yeah. Okay. Hi, hello. Oh, thank you. Yeah, unfortunately, I don't have socks, but I have full knowledge. Hopefully, they won't be too shocking to you. So AlphaGo, everybody knows that, right? So AlphaGo is superhuman. Language model not yet. So how can we leverage knowledge from AlphaGo to improve language models? Reinforcement learning. Hopefully, you know that. You know, it's about agent learner and decision maker for agent. You know, nowadays many people are talking about agent. Oh, the last 2 talks they are talking about agent. But what's agent? You know, hopefully you want to learn something about reinforcement learning and AI. You know, those types. Don't just follow news or social media. Trust me. Okay. Yeah, actually, I'm quite crazy, so be careful. Okay, lessons from AlphaGo series. For AlphaGo, you know, we have perfect model. We know the rules, we have perfect model, so we can generate infinite high quality or even perfect data. So we can learn from this perfect data. For language models, they are not perfect models. So if we learn from those imperfect models, we have something wrong. And there's something also important. If the learning is not done. And you know, language models like GPT, they are basically imitation learning. Okay, language model. Last 2 speakers have already got good instruction. So I want to say something about language model. You know, like total repeats is basically a policy. So when we do policy, it's related to reinforcement learning. There is a paper. It's released in 3 months. The performance of API checked a lot.
That's a big problem. So, people are talking about foundation models, about iPhone model, even operating system model. But, we have this kind of problem. For highway, it's transparent. For information highway, it's basically transparent. And we have some problem, it's relatively easy to fix. How about those learning models? They are big, opaque black boxes. If we have some problem, we don't know what happens. Even we don't know how it works. So can we really treat them as foundation? So that's something, I will throw lots of questions to you. So hopefully you are not sucked too much. Okay, so how to handle this thing? There's something called iterative improvement from feedback. That's the title of my talk. So you can see those items. Say graded design, that's a bit very basic of optimization principle or method. And the last one, also our human mind. Iterative improvement from feedback. I think that's a basic principle. So we should follow that. Typical, those large models, it's very hard to follow this kind of iterative improvement from feedback because they are too big. Every month or every 2 months, we update once. We cannot adjust to these changes too quickly enough. Okay, this is basically my outline, but not too much time, so I won't say. There's basically a study from MIT basically says GPT-3 is good at language, but not good at functions like say factuality, like reasoning, those things. So we try to leverage those good language abilities, but not functional. We try to improve those functional competence. How to improve? Okay, pre-tuning, fine-tuning, prompting, parameterization, or with some tools. Okay, too fast. But I have 39 pages slides, so I have to be fast. Pre-tuning. Okay, people probably know BERT, B5, B3. You may not know. Tackle, Smart, ADA, there's something new called Web Agent. They do planning in the pre-training stage. For the first three, they are, the traditional or popular language models. They don't do planning in the pre-training stage. But, if you want to do agent, auto agent, baby AGI, those popular terms, they are cheating you. Since the language model, they don't do planning intentionally in the pre-training stage. So we need how this kind of planning ability. So we need to do that. So this web agent is from Google. And the plan how is a language model from Google. And they developed a new HTML file only for the web navigation. So they do this web navigation competence in the pre-training stage. Fine-tuning, okay. People probably know super fine-tuning, learning from human feedback. There are many of them people, the last half year, it's like crazy, Every day we have some new papers. So I try to keep up with those many papers and, put them in a beautiful table. And prompt, okay. Prompt, prompt engineering, everybody knows that. Yeah, actually, many techniques, they are about improving prompt, these days, mainly mainstream method. Here I want to say, basically, this is, just something about open loop. We don't do closed loop. We don't have feedback. Here I want to say, the other deep learning, they can, using AI or machine learning techniques to automate the prompt. So I think that's an interesting way to do that. Okay, so I want to say briefly, nowadays people do lots of prompt engineering. There's something like when you have some new product, you want your grandma to use it easily, right? So for ChatGPT, you need to figure out all kinds of tricks to use prompt to make it work. Sometimes you don't know what happens. So there's something wrong. We need to improve the adaptability of these language models. to make our grandmas happy. Closed loop feedback of the cover. But anyway, closed loop. Okay, closed loop, you know, if you know something about, for example, control or something. But I think that also, you know, intuition, you know, we need some kind of feedback to improve successful. So these are closed loop methods, but you cannot, okay, it's with a self-reference to fix language models. So something wrong, because language models fixes, all language models are not perfect. If we self-refer to those imperfect language models, there will be something wrong. So we need to do something better. Yeah, actually in NLP, there's a very fundamental problem about ground truth. Nowadays, many methods, they do let me copy this. Say self-generation and self-evaluation using language model. You know, sometimes people using GPT-4 to generate data and train another model. And they use GPT-4 to do self-evaluation. So where's the ground truth? You know, that's a problem. And optimality, you know, AI, and we hope to have some optimal solution rather than just okay or feasible solution. Okay, this is a big, maybe a surprise to you, but AGI, you know, people are talking about AGI. But, you know, in optimization, there are two principles. The first is, but they are very intuitive. When we have multiple objectives, usually we cannot optimize all those objectives, right? Very intuitive. Another is, when you have multiple constraints, the more constraint, the tighter constraint, the less chance to find a feasible solution. Two intuitive principles. Okay, if you accept, you have to accept these are principles. With those two principles, what's the meaning of AGI? You know, nowadays, all the people are talking about AGI. It's wrong. Anyway, hopefully you're not surprised too much. But anyway, so we need to bridge the learning model to real time. In robotics and deep learning, we have something about simulation to real time or sim to real time. So I call this term learning model to real time. So when you have some learning model like GPT or something, we need to break this gap. Otherwise, there will be something wrong. So we need to do something. Okay, let me show you some examples, simple examples. GPT-4 cannot solve all the 3 or 4 digit multiplications. You know, very simple problem. On 24 problem, you know, you have 4 cards, and you try to get 24 out of those 4 cards. But you know, first year programming assignment, just use recursion, you can do it. But GPT-4 and this string of stuff, that's a very advanced technique. This will, you know, from 4% to 34%, that's very big improvement, but the problem is they cannot solve all the problem 24. So something wrong there, right? And for the Othello, that's a game, the black, white pieces. They're still trying to figure out the legal moves. So those language models, in particular GPT or ChatGPT, they still cannot handle those simple problems. Now, you know, many people are talking about agent. So where's the confidence? Okay, I'm too creative, but anyway. Okay, this is very creative. You can see it, right? Language model based autonomous agent is a big problem. You know, people are talking about agent, AutoGPT, Baby AGI, and you know, all kinds of those projects. And some startups, they got big investment. But nowadays the language models, they are learning from text. Just think about simple case, swimming. You know, we learn from reading books, from watching videos. Can you learn swimming just by this? We have to jump into water and struggle, right? And then learn it gradually by interaction with the world. So we need something more rather than just text or even video. We need, yeah, swimming is a very intuitive example. Okay, IT versus AI, maybe. IT, just like we said, is especially transparent. What we see is mostly what we can guide. It's very transparent. But AI sometimes is very opaque. We don't know if something wrong happened. We don't know what's wrong. You know, like GPT-4, like those very large models, they train them for using millions of dollars. If something wrong, can you fix it? Can you have some system more capable to handle the problem by those super giant language models? So something wrong with those language models. And you know, I want to say ITR and AI, they are very different. So we need to think carefully before we launch an AI project. Before, you know, like we see, we want to invest AI project, especially language model project. Be careful, especially agent. Okay, stochastic error. That's a debate. So we cannot learn language from radio, internet, television, ourselves. We need to have interactions. Let me see the time. Okay, let me be a little bit faster. Okay, there are 5 word scopes from the labeled text to internet text to multimodality to embodiment. Embodiment means interaction with the physical world and the social interactions. So we need all those things to have a very good language model. Say for grounding, for agency, you know, we need those elements to learn a good language model. Good news, there's something already happening, although not many people know about those. So, you know, if you want to do agent, probably you want to check those, and they have to do something already. And also the web agent, but that's for pre-training, so I put it earlier. This one is, there are 2 language models. One is after. After they use, like say, before those things. And they also have a retrospective language model. So for that one, they updated literally with all the feedbacks. So they are tempted to improve that retrospective language model. So I think that's a good way. Modularity small models, tools. Okay, I will be a little faster. Small models like tools, you know, all kinds of those. Yeah, Alpaca. And small models, even, you know, traditional models, they can sometimes they have better performance than language models. Okay, this is, you know, historical, very big computer and iPhone, very small but very powerful. You know, very large language models. Now we have very fast iterations. Maybe in 2 or 3 years we can have smaller but very powerful models. Yes, let's do it. Okay, so this is a summary. You know, we improve language models, pre-training, fine-tuning, prompting. I want to say feedback, you know, open loop or closed loop, and also for language model itself, whether it's fixed or iterative improvement. You know, I highlighted. So we need to do iterative improvement for the language models to make it work better. Okay. This is about learning search without fundamental method, and it's also about it's also about, you know, data and optimization, and you know, we need to make those things work together and have better performance. Okay, agent. So we have data, training, or evaluation, and inference or interaction, and we may have some model-free method, like indicated learning, like standard and model-free learning. And we may get some model. You know, the model may be from rules, like, you know, chess or Go, or maybe like, you know, some physics, Newton's law. We have those rules, or we have maybe have approximation. Language models are approximation, or we may have simulator. You know, some simulator are good, some simulator are just approximation. So, but you know, we can have this kind of models, and using those models, we can use model-based method, like, you know, classical planning, like open research, optimal control, or model-based learning. And you know, this is a big cycle. We can do it. Iteratively improvement from feedback and improve it gradually until perfect. Okay, so this is something I want to propose. You know, we have module 0 is a coordinator, and we have N modules. They work together, coordinated by module 0, and also with the tools and APIs, they work together to achieve some task. Basically, I want to say the current language model center way is not perfect, so we need to think something more to have better results. So we work together, you know. If we do this way, you know, modular, smaller models, then it's friendly to smaller players like academia, like small startups, even individuals. You know, it's great for open source, decentralized, democratic. This reflects the wisdom of crowd. And you know, blockchain is good. That's good for the ownership. Okay, I recently wrote something. Yeah, basically this talk is about this iterative improvement on feedback for learning models. Yeah, connect with me like email or LinkedIn or Twitter or somewhere. Okay, thank you. Okay. I don't know. Questions? I don't know if this too surprised or not. Okay.
That last slide, where you said smaller model, is there a disadvantage having smaller modular like model?
It depends. You know, actually, recently, I don't put something there, but I just got something on the Twitter. It says it using text to SQL. They can have better performance than GPT-4.
So in the last slide, you kind of had model 0 and model.
Yeah, model 0 is coordinator. And the other modules, they work together with coordinator. Maybe, you know, GPT-4 can be a module. Yeah. And here you can see the Gorilla, they can have better performance than GPT-4 for the data cost. So it can be it may be the coordinator of one module. Depends on your application. You know, that's a general abstract model. So more questions?
Once or twice.
Okay.
All right. Well, yes. Thank you so much.
Yes. Okay.
Okay. Our next speaker, let me bring up the.
Sorry. Okay.
Yeah. So our next speaker, David, and David is not available today, and we have a new speaker. She will talk about building safer AI with AI compliance agent.
Here. Yeah. And also you need to share your screen. Yeah, share your screen. Yeah.
Hello, everybody. I'm from Fairly AI. What we're building is the compliance layer for AI. We are actually working out of the Techstars Toronto office here at 111. So just around the corner, come say hi anytime you're in the building. All the 3 presenters were great, but we're solving the last mile problem. You can spend a lot of time building a lot of cool AI models, but we know that there's a term of POC graveyards for data science models right now because they get stuck at legal and compliance, especially in highly regulated industries. We literally talked to a bank here in Canada where they spent $2 million 2 years building a cool AI model, but we got stuck at compliance because no one in second and third line, they call them. Independent QA is the second line, internal audit is the third line. No one in those line of defense know how to validate these models. So the problem we're solving is really this. We help data scientists pass this last obstacle, but also help companies save money on their compliance paperwork. Because when you talk about, upcoming AI regulation, like the EU AI Act, like the US, California just passed their first draft of AI regulation this morning. Canada has our Bill C-27. All these things talk about accountability, transparency, even explainability. It boils down to a lot of compliance paperwork. We solve that problem so that your whatever AI project you're building can eventually go to production. And we saw this problem from our own experiences. David, unfortunately, can't be here. He actually taught ethics at Cornell and Berkeley. And then after grad school, he joined an AI startup back in 2014 using NLP to do cyberbullying detection on social media. Even though he taught ethics became on the back burner. He built 50 cool AI models in a span of 6 months. But as you can imagine, like using NLP to do cyberbullying detection has some real ethical issues. And when that company was acquired a few years later, he became the CEO and board member. He saw the problem on the other spectrum. When you're at the top, you really have no visibility on what the data scientists are building. So who ultimately decides whether the AI model is ready to go to production? Average days, months to build the AI model, right? Is 98% accuracy score good enough, or is it 99%? Sam came from IBM. She actually was one of the original committers of Eclipse C++. She's our CTO, and she worked on some Watson products, same problem, where she was using AI to build one of IBM's first AI medical devices. Compliance was like, she was asked to fill out 200 pages of document that she had to sign to say that she understood what she's building compliant. Right. Hassan is our director of global AI policy. He's a JD, lawyer that can code. And he literally sits on the Canadian Ethical AI Standard Council right now, and he's part of the Biden-Harris NIST AI Risk Management Working Group. So we help you translate all these regulations and compliance requirements so you don't have to. I'll skip this slide, but basically we work with people that are already trying to solve these problems. And here's the concept, right? Like the larger your compliance legal department at your company, the more safety first approach they take. And that means in your mind, probably minimizing the innovation. And when you're on the other end, the red spectrum, you're probably a small startup that has no legal compliance department. So what is just right? And this is from Anand Boss, who's teaching product management at Stanford right now, came from product management roles at NVIDIA, Yahoo, eBay. What we're proposing is really this. You can move fast and be compliant by using automation. And when I talk about compliance, I'm really talking about different kind of risk. Even though we're called Fairly AI, people assume we only do fairness. But as the universe of AI system expands, and AI system is a term coined by Gartner, they are industry analysts. It means trust, risk, and security management. So where we see ourselves sit is actually at the top here, right? How do we manage the unknowns right now as technology is moving so fast, regulations moving so fast? There are two parts of product. First part is a platform for your legal compliance team. What you're seeing here is a dashboard, but also a set of controls at the top right corner. Those are typical data scientist metrics, and that's the part I'm going to focus on today because I know a lot of you, data scientists have a development background, so that's probably the part most interesting for you. So we exist to be the translator between the data scientist and all your non-technical folks. So ultimately, it's a business decision whether your model is good enough or not to go to production, right? Just like How do you know 60 is pass, 59 is a fail in the traditional education system? Because someone set up the policy, someone set up those business rules up front. So same idea we're applying here. It should be your legal compliance business team that decide whether your model is good enough or not. So data scientists, you just build cool AI models. This is at a high level what the workflow looks like. We have a library of policies, library of controls, those map to text, and then text becomes reports and dashboards. The main thing here is that the monitor and analyze the set of text actually came from a proven model risk management framework from the financial services industry called SR 11.7. Because banks actually have been using AI the longest, they have so much data, they have been using quant statistical models for the last 50 years. AI model is another type of advanced analytics, right? So these kind of tests, you might have heard of Google's what if tool, for example, is what the banks have been using called sensitivity tests. So we're really expanding those model risk management concepts into AI. So how is detecting, so I'm using bias as an example because that's one's easiest to understand, right? But just keep in mind that the framework can apply to other kinds of risks, just not just bias risk, right? So in what we now call traditional AI model or narrow AI, as Professor Botts like to call it, right? When you're using a narrow AI, really means if you take it out of its use case, out of its context, it becomes useless. With generative AI, you can use ChatGPT to write a birthday card. You can use it to write marketing plan. You can use it to, build propaganda. So how do you make sure it's safe, right? So this concept really is about that. So in traditional AI model, in this example, building a prediction model, you put training data, you train it, and then you have some prediction. So to test it, right, using our Athenian, you really have, it's very like testing traditional software, right? You give it your test data, but also your expected outcome, run our test against controls and policies, and you get a set of results. So the difference here between traditional software and like AI test results is that traditional software, you pretty much always have binary results, whether it pass or not your test case. But in AI models, because it's probabilistic, is thresholds that you're testing against, essentially. If your policy requirement says, if your threshold is exceeding 98% is a pass, then you pass, right? That's what the auditor is looking for. That's what the compliance team is looking for. So we streamlined this process for you by setting up those requirements up front. But what about LLM? That's like the topic of the day. So what we do is really combine the traditional way of testing AI models with prompts. So now you not only fit it test data, expected outcome, but also augmented prompts to combine the two to come up with the test results. And something passed or not based on the policy and controls that are set up upfront by your legal compliance business owners. So we are in a closed beta right now. I'll put this slide up later after my demo, but we would love to get your feedback. And we're already on Microsoft Azure Marketplace for our platform side of things if you want to start with our platform. Let me go here. So I'll start with the notebook. So in this example, what we have is a notebook that got some data from LinkedIn profile and trying to determine if the job candidate should be hired or not by asking it some prompt questions. So we mapped a OpenAI language like ChatGPT with a classifier model. What I really want to show you is this, right? We already come up with prompt example, like this set is like fair questions to ask the candidate. This one is like unfair. But the idea is that after you train your model, you prompt a question, you run the same set of controls and policy on both set of prompts. And then that's how you know like what value you get. So your data scientist or yourself don't have to guess, okay, should I send these 22 metrics to my compliance team? Would my compliance team approve this or not? No. We tell you ahead, these are the 22 requirements you need to send to your compliance team. So as you're training your model, you already have a goalpost to work against. And like the threshold is something that is already determined upfront. So these 22 controls, right? How do you get those? We use a Python command line tool and configuration file. Essentially, is what's underneath the hood. So a config file is in a JSON format that you can download from our platform, just like a lot of web analytics product. If anyone's in the web space, right? You download a JavaScript file, pass to your developer take care of the rest. Same idea here. Your compliance team pass your JSON file, you take care of the rest. You run a command line tool. So like 22 controls, so back to the concept of controls. So it's the same 22 controls as in your config file, essentially, right? And you run one line of command. Sorry. Here. So run line of command, you can summarize the results, same 22 controls, same 22 metrics that you collect. Because it's a Python command line, you can integrate it into your CI/CD pipeline, which can be integrated into LangStream or LangChain, you know, any of these ops tools. And then the output actually get output back into a JSON file. So for those of you who work in large enterprises that are already working with Tableau, Power BI, you can ingest the data into those visualization tools. Or if your team, your compliance team want to have a purpose-built dashboard for their needs, then that's when they upload it back to our platform. So here's an example of the chatbot, recruiter that I just gave, but this now is a view for the legal compliance team. The idea is really they set up the policy requirements. So we actually have a client that built one model at a bank, and they have to write 72 reports because the model is used in 72 different jurisdictions around the world, right? So how do we press one button and create 72 reports? It's ultimately the North Star we're solving. We might never get there, but we do a lot of mapping behind the scenes. So we really want to just answer one set of questions to comply with as many regulations and rules as possible. So I flashed a screen about the different organizations we work with. So ISO is actually one that you should pay attention to, especially in the highly regulated industries, because we've already done work with like standards institution where they're all looking at using ISO standard to audit against whether the AI model gets approved or not, right? So these metrics is basically what I just showed you from the command line tool from the notebook. We ingest it by, either just importing the JSON file back, or we have a REST API that you can use to ingest. What we do different from existing data scientist tool like Arise, Fiddler, Jira, all that is we really only look at it from a compliance angle. We don't have lots of graphs and charts because our target audience for the platform is the legal compliance team. And they all tell us that we don't actually understand what all those graphs and charts are. Just tell me if this AI is high risk, low risk, or medium risk. And that's what this graph is showing you over time for compliance regulatory monitoring reasons. And the last thing is back to my North Star. How do I create multiple reports, right? So for your executive team, like a lot of time is like hard for actually a data scientist to explain to your business owner, what did I build? Why is this model good enough or not? So we solve that problem for you by having these report templates upfront. And ultimately what we built is a framework, a library framework for policy controls, tests, and reports. So it is highly configurable depending on use case and context. So we work with domain expertise best in class in different industry to come up with these different policy controls, tests, and templates. I'll leave it there and answer any